Okay, so what did we think on 1.3? I know I went over a few of them. Is there any that are sticking out that you want me to go over a little bit more? 1.3, anything you want me to go over a little bit more? And the probability of B such that A is going to make a little bit more sense after today because of how we're going through the tables. Yo. Any other problems from 1.3 that you want me to go over? We went over a few. We did like the Venn diagram last time. A couple of others. Shay, did you have 1.3 worksheet done by chance? Sweet. Anything from 1.3's worksheet? We good? Ready to move on? Some of you are talking too much. All right, so a couple of you need to finish the quiz because you ran out of time, or you need to take the quiz. My schedule today is I don't have any meetings, so I will be, after this class, down in my office in the Career Tech Ed building, which is across the parking lot. Office 200. Come upstairs. If you can't find me upstairs, go downstairs to Office 100. Ask the ladies down there if they know where I'm at. Sound good? And then there was something I wanted to run over real quick. So I have this statistics book I just decided I'm going to bring it and start going through it, because sometimes me winging through a piece of data on a skeleton thing of notes, sometimes it might be kind of goofy. I want to talk about. So, what page is that? 74 through 76. So I just want to review. This comes out of the other events, or the other situations. So let's talk about mutually exclusive first. Okay, these are notes that we've already talked about. Just please make sure that when you think about mutually exclusive events, you have these two events, and it says this. Let H and H2 be events. H1 and H2 be two events. Okay? The union of H1 and H2, so this stands for and. This means the overlap of the two events is going to be the empty set. Why can I say that's an empty set as far as our diagram goes? Do our circles intersect? No. So there is not anything in common between the two events. They're mutually exclusive of each other. Okay, so if I were to say event 1 and event 2 happening at the same time, it doesn't take place. It's not like you're drawing a king and a red card. Okay, both those events can take place because there happens to be two red cards that are kings, so that could take place. That's not a mutually exclusive event. A mutually exclusive event with the cards would be if I draw a king or a 3. Those have nothing to do with each other than they're part of the deck of cards. Okay? So that's the first thing. Then complementary events. A complementary event is like this. You have a single event that takes place, and everything outside of it doesn't take place. So that would be, if you were to take an event, you know it's complementary if you take the event, and so all the outcomes of it happening and all the outcomes of it not happening, the probabilities will add up to 1. That would mean they're complementary to each other. If it was 80% of rain tomorrow, that means it's a 20% chance that it won't rain tomorrow. Okay, those are the complements of each other. I'm just trying to go through quickly. Non-disjoint outcomes. So outcomes H1, H2 are called non-disjoint if and only if they have at least one element in common. So if you share one event, if I want the King of Hearts or a hearts. There's one event that's in common between the two. So non-disjoint events, it happens to be where you're going to have some sort of intersection between the two that you're going to do. And these Venn diagrams don't have to just be circles. You could have it as a rectangle where they overlap each other, things like that. It's just a way of visual representation. And then obviously you know that there's multiple outcomes that can occur. We talked about the Venn diagram where you have 3 circles, where you share any 2 circles or all 3 circles, or you're all just independent of each of the 3 events that take place. Okay, so follow along in your notebook if you have it. If not, it's recorded, so when you go get your notebook, we can run through it. So this is section 1.4, and let's talk about this. This is going to make the probability A such that B make a little bit more sense. So you have musicals, science fiction, comedy, and then the total. And then across the top you have age breakdown, 18 to 23, 24 to 29, 30 to 35, and then the row total. And they give us the numbers of 8, 12, and 9. They give us the numbers of 15, 10, and 8. They give us the numbers of 11, 8, and 12. And this just says, consider the following contingency table. So this is another way of just representing our data. Representing the poll taken of 93 people from 18 years old to 35 years old. They were asked to pick their favorite movie type. So there's only 3 movie types that they're giving. Asking the group to choose one of those. There's not an option to pick something other than that. When you come across a contingency table, first thing you should do is add up. So get these totals. So that's 29. Just add those straight down. And this is 33. Just add it straight down. This one is that 31? So I'm just adding straight down each of the columns. Then you should also add across the columns. So you get 34, 30, and 29. And where people make goof ups in statistics is in arithmetic. So if I add the sum of the rows or I add the sum of the columns together, you need to get the exact same number. So if I add these 3 numbers together, I get 93. If I add these 3 numbers together, I also should get 93. Is that okay so far? Can everyone see that okay, or you need me to dim the lights? We're good? So again, this is on 1.4, talking about contingency tables in your book. And then they want us to go through these particular events. So let me split the board. And let me dim them just because it's going to be a little squinting. All right, so the first one says we want to know, find the probability of 18 to 23 that years old that like science fiction. Okay? So we wanted to find if we were to select somebody at random, if we were to have these 93 people in the class, it was an anonymous survey, but then I were to come up to that person and said, what do you like? How old are you? If you don't mind me asking, you tell me you happen to fall into that range, and you like science fiction. What is the probability that's going to take place? Well, how many 18 to 23-year-olds happen to like science fiction? 12. There's 12 that like science fiction, but if I had all 93 people sitting in the same location, I have a 12 out of 93 probability of picking somebody within that age category as well as having to like science fiction. So as I progress through these, it's going to get a little bit more involved, but if you think through it a little bit more of how the data is broken up, you should be able to start figuring things out. So probability of someone who likes science fiction. Okay? So how many people like science fiction? 30. Am I worried about an age group? No. So there's 30 that like science fiction out of how many people we're dealing with? 93. Is that okay so far? And this is where we start getting a little bit different. So we want the probability that you like science fiction such that you're 24 to 29. Okay? So this is basically how I'm going to take this. I have all 93 people. And then I make a general announcement saying, hey, if you are of ages 24 to 29, come over here. Okay? I'm not worried about the whole group. I'm worried about just the 24 to 29-year-old people. How many people are age 24 to 29? 33. Does that make sense? So that's my denominator. So how many of those people happen to like science fiction in that group? 10. So again, let me repeat that because it's something that I think when you visually see it, it makes a little bit more sense. So I have 93 people in a room. A general announcement is made that if you happen to be ages, fit in the category 24 to 29, come over here. The other people stay on the other side of the room. And then what is the probability that those people in that group would like science fiction? That's the such that happened. Okay? What's the probability that I were to pick somebody of this group of 93 people that like science fiction such that I separated part of my group, the 24 to 29-year-olds were with me, the rest of the people in the group were still sitting behind, not being selected. Does that make sense how I just presented that? It's a little bit different to think about, but when you look at the table, it should make a little bit more sense. Then letter D is, I want to know the probability of 30 to 35-year-olds such that musical. Okay, so how do you think I'm going to approach this one? If you look at the other one on the opposite screen, which number was the denominator as far as our categories went? Yeah, second one. So, what's my denominator going to be on this new question? 34. Why 34? So this is what's taking place in this case. I have all 93 people all back together. They're mingling, chatting about their favorite stuff. And I'll say, hey, if a musical is your favorite type of thing, come with me. That just happens to be that group of people with the musical. It had to be all age levels. Okay? Now, how many people that are in the musical category happen to be, what's the probability if I were to take that group and say, how many fit into the category of that age? 11. Okay? Does that clear things up a little bit more on how we went with these a little bit? All right, so now I'm going to go back to this board, and I'm just going to wait, get out of here. Clear. No, I don't want that. There we go. Erase this real quick. All right, so now we are going to letter E, which is the probability that they like science fiction or comedy. Okay? Am I taking any part of the group away? No. I'm not saying, hey, if you like science fiction or comedy, come over here and let's figure out the probability. I want to know if I have my whole group of 93 people, how many of them like science fiction or comedy? So I know I have 93 people that I'm worried about. Science fiction or comedy is how many people? 59. I'm going to take the total number of science fiction fans, total number of comedy fans, add them together. Letter F, probability that they don't like comedy. They don't like comedy. How many people are we worried about in this case? All 93. How many people like comedy? How many like comedy? 29 of all the groups. How many would not like comedy then? 64. So I took the complement of liking comedy to not liking comedy. And then find the probability, switch another color. Find the probability that we like comedy or we are 24 to 29 age bracket. Okay? So we got to be careful here. Why do I have to be careful dealing with this? Do what? Why is that? So you don't want to count somebody twice. Does that make sense? You know when you, little tangent, you're like, oh my gosh, it's only been 20 minutes. Tangent. You know when you take the ACT or SAT, and there's the demographics you're filling out on the back? How many of you feel that you're kind of like, I kind of don't really know if I fit into any of these, but I'll just bubble white Caucasian because that's the closest to me? That's just a way of separating people. Now, the reason I don't want you bubbling multiple bubbles is because then they're like, well, shoot, now we got to count this guy. How many different times did he count the different demographics of this person? So, what? Yeah.
So, but also, if you were to have a lot of different bubbles, then it would limit the amount of people per bubble, right?
Right. Yep. So that you actually hit a valid point. In education, it's just this big. You guys have been a part of this whole thing for many years since your education has started. It really started with George Bush, and thank God his wife Laura was a librarian, so her understanding of how things took place in the classroom were very well understood. She was a librarian. But they created something called No Child Left Behind. No Child Left Behind was an absolute train wreck. Now, I'm Republican. I'm as Republican as they come. I will tell you that No Child Left Behind was one of the biggest errors to take place in public education because we focused on things that were so negligible, but we put more time and energy into it. And this actually took place earlier this year. I was at a meeting, district meeting, and I was sitting with the Cherry Creek administration, Cherry Creek High School administration, and we noticed that last year's graduating class, of the categories to subcategories to subcategories, we noticed something. We noticed, you're not going to like this much because it's going to offend you a little bit. We noticed that 100% of our Native Americans who are on free and reduced lunch that came from a single family were not college ready. 100% of the kids from Cherry Creek that were African American or Native American, single family, and on free and reduced lunch. And that 100% stood out. We're like, oh, dude, you have 100%. You want to know how many kids that was? 1! So they were either college ready or not, but the people were at the table going, 100% weren't ready? 1 kid. That's all we had to fit that category. And that kid just didn't have to be college ready. But they looked at it going, oh my gosh, what should we do for this 100%? We're talking about 1 kid that fell into that category. But No Child Left Behind said, hey, now we're going to exploit the whole thing. We start looking at percentages versus people. And so Cherry Creek High School, under No Child Left Behind, could have failed in that category. And lost its accreditation because they were worried about one kid. One kid. But it was the percents that was goofed up, and that's where it gets to on those categories, subcategories, subcategories, and you keep going. Because what they wanted to do is, we got to find out where we're really missing the mark. You know, if you are of this descent, of this marriage, and your parents make this much, and you happen to have this, and you happen to have 3 televisions in your house, and you happen to have 2 pets named Roscoe, look at that. You didn't fit into this category. You failed. We're talking about one kid. And that's the bad thing. Now, what does it matter with that one kid? Well, I'm sorry that that one kid wasn't college ready. Did the school fail? No. You're talking one kid. That could have been any kid, but it's just because that kid fell amongst this category that it was like, raise some flags. You know what? Maybe we should, we have to teach throughout summer now because we had one kid that was 100%. So that's how silly some of those categories get. And that's why I truly feel that No Child Left Behind was the uttermost train wreck in public education. You know, I taught many years at an inner city school. I taught in Reno for many years. Reno's population, when I lived there, had a larger gang population per capita to anywhere else in the United States. Okay? What I mean by that is we had 250,000 people that were living in Reno, Sparks, and Carson City and Washoe Valley when I was living there. There was over 100,000 gang members there. God bless you. You go to Watts, LA, in less than a square mile, you have more than 100,000 gang members. But if you take the whole Los Angeles area, it's a much bigger population that's not gang. So I had kids that there was like 8 events that had to take place in their lives before school could take place. Let me repeat that. There was like 8 events in this kid's life that had to take place in order for that kid to make it to school. Now, you guys might have 2 events that need to take place before school happens. Your alarm has to go off, and you have to find your cell phone. And I'm not trying to make fun of you, but there's just different opportunities. Now, I remember the superintendent of our school district back in Washoe Valley, the Washoe County School District, had told all of us, and this was the biggest contradiction in the world. He said, Wooster High School, you are failing. You are failing miserably, and we're going to fire each and every one of you teachers. Because, it was the teacher's fault. This kid was inner city, came from over the border. Most of them were illegal. What do I have against the people that are illegal? Nothing. It's just I'm saying that's what these people came into. They had a different scenario than a lot of other kids had. It didn't have anything to do with the teacher. And the most beautiful thing is the superintendent's saying this to us. On the flip side of the coin, Newsweek published their top 1,500 high schools in America. And we were ranked number 46. So we were the 46th best high school in the United States. But the superintendent's telling us, I'm going to fire each and every one of you because you're not doing your job. You want to know what the difference was? We had an international baccalaureate magnet there. So we had kids that were trucked in all throughout the district that would come to our school to get their international baccalaureate. We also taught those kids AP. So Newsweek had their criteria was this. Number of graduating seniors is your numerator. Number of AP and IB tests given is your denominator. You know what's beautiful about IB? You have an internal and external assessment. So every kid who takes an IB class counts as 2 tests. So our number of graduating seniors was the numerator. Number of AP and IB tests were the denominator. We happen to fare very well. Now, let me give you a stat that's going to scare you a little bit. We even have over 400 freshmen. I know that's small compared to this school. Our graduating class, 90. We would lose 300 plus kids from freshman to senior year. So we were failing in the eyes of the superintendent. As far as Newsweek, and let's publish this nationwide, we were doing pretty damn well. What data did us teachers love? Newsweek. What's the superintendent do? I'm going to fire all you guys. Then we go Newsweek. Hey, we all got fired, but you rated us number 46. That's national news. That says, superintendent, get out of here. You just fired teachers at the 46th best school out of 1,500 that we tested in the United States. Think about that. Remember I said you're going to find data or you're going to find studies that you will agree with because it satisfies you? That's this. So, where'd my notebook go? There it is. So, I want to know how many people like comedy or are fitting into the 24 to 29 category, and I have to have 8 less. How many? 54? Do you agree with this? So, comedy, the number of people like comedy is 29 people, right? The number of people that fall into the category of 24 to 29 is 33. And there happens to be 8 of those that we don't want to count twice. So we either have to eliminate them from the comedy bracket or the 24 to 29 bracket. You eliminate them only from one of them. And then are science fiction and 18 to 23 independent of each other? What do you think? What are independent events? Rely on each other? Let's look with the independent outcomes, 7172. Independent outcomes. 2 outcomes, A and B, are independent if and only if the occurrence of one does not affect the probability that the other will occur. We write it this way. The probability of A and B is equal to the probability of A times the probability of B. The situations in the Venn diagram, they have an overlap. Okay? So, are science fiction and are 18 to 23 independent of each other? Here, here. Independent or not? They're not independent events of each other. So, to show independence, you need to show that the probability of science fiction is equal to the probability of science fiction such that 23. So let me erase here so we have room so we can look at our diagram. Bigger eraser. No, I know. It's more fun to draw. Thanks, though. All right. So I want to show that is the probability of science fiction equal to the probability of science fiction such that 18 to 23. Okay? Probability of science fiction is what? 30 out of? So is 30 out of 93 going to be equal to the probability of 18 to 23? So that's what? What's my denominator on the other one? 29? This might work. I don't know. What's the probability of science fiction? 12 in that category. So is 30 over 93 an equivalent fraction to 12 over 29? I'd say to get to 12, we have to divide by 4, but if I divide 93 by 4, I don't get 29. So these are not equal to each other. These are not equal. Therefore, 3 dots like this, or means mi viva loca. If you're part of the gangs, little 3 dots on your left hand, stands for your crazy life. Therefore, not independent. How do you know that? Well, teach in an inner city school, you'll learn things. How are we feeling? Feeling okay? That clear up a little bit about what we had gone over? You want to know, my opinion, one of the worst things teaching at an inner city school was? They said, you, male teachers, you're in the hallway to break up fights between classes. You know how smart these gangs were? They would take two of the 14-year-old little wannabes that haven't been jumped in yet and say, hey, do us a favor. Go way over on this side of campus and start beating each other up. So they'd be on the other side of campus beating each other up. So you got a fight taking place on campus. Everyone's got to go see a good fight, right? Dude, sweeties, 14-year-olds are beating up each other. So everyone goes over there, including the administration, including the cops. Opposite end of campus. Someone's getting jumped in the south side at the same time. So myself and other teachers, we'd go swimming into the guy's bathroom. There would be one guy curled up around the toilet getting stomped for 4 minutes by 4 guys. That was the jumping initiation by south side. We'd be tossing kids back. No, Dave, mister, he's got 90 seconds left. Come on, mister. Like, he's done. His jaw's going the wrong way. Oh, that's messed up, mister. And you laugh. And I wish I could be joking about it. But I wish there wasn't. Okay, next page. Next page. So I will tell you that this is my first year wearing an actual tie. I did it out of respect for you guys. But I used to always wear a dress shirt. There was more times I had ruined dress shirts because I'd be pinning a kid to the floor. Another one of his buddies is sitting there punching me in the kidneys, ripped my shirt. Or, the best, is when Southside and the Playboys would get in a fight with each other out in the middle of the parking lot. So we'd be out there breaking up the fight, and the cops would show up and say, let's just do a mace bomb. And all of a sudden you see this cloud of stuff coming at you going, oh no, it's coming. And I got to teach in 5 minutes. So you'd be pinning a kid to the ground going, uh-oh. Ow, my eyes. Oh, it burns my nose. And you're choking up everything. And then I got to walk into class and my eyes have pus and snot coming out of them. My nose does. Hey, mister, you okay? Yes. I remember our football coach named Joe Sellers. Guy always was chewing tobacco. I don't think he ever once didn't have a dip of tobacco in his lip. I remember him standing on this kid's back. The kid's laying on the ground. He's just standing there looking around. The kid's laying on the ground. He's standing there. Hey, get that kid over here. The kid's laying on the ground. Kid wasn't moving. I don't know if you're supposed to be standing on the kid's back. Oh, Joe. Yeah, you know. A lot of him to figure out where you need to spit his coat in. The table below, this is on the next page of your notes. The table below summarizes a group of randomly selected high school students. They are broken down by gender and whether or not they were wearing jeans. If a randomly selected one student, find the following. Okay? So let's create this. So we have males, we have females, we have jeans, and we have other. All right, 12, 8, sums 20, 5, 11, 16, and then our totals is 17, 19, and 36. So they already have this table filled out. You know that 20 plus 16 has to equal 36 as well as 17 and 19. So what is the probability that a person is male and jeans? Male and jeans is how many people? 12. Out of how many people? 36. Okay? What is the probability that, so what is the probability that a person is male wearing jeans? What is the probability that a male is wearing jeans? A male is wearing jeans. How many males are there? 17. How many of those males are wearing jeans? So this is the M such that J. Okay? M such that J. Can I move on? I'll just move over screen. What is the probability that someone wearing jeans is a male? The probability that someone's wearing jeans such that they're a male. What is the probability that someone is wearing jeans is a male? So are we worried about? So how many jean-wearing males are there? How many total people are we talking about? Huh? 36. So this is like I got 36 people waiting there going, all right, there's 36 of you. How many males are wearing jeans? Dude. Got them.
Aren't there only 20 people wearing jeans?
Wait, which one am I on? Probably, maybe I looked at the wrong area. Oh, I did. Oh, boy. Oh, you are right. Sorry about that. It's 12 out of 7. I'm so sorry. Wait, 20. Damn. 12 out of 20. Well, I tell you, I got to quit sniffing glue before I come to class.
Would it be M over J?
Do you though?
Do I know? Yes. Brother Smith today. What?
Wouldn't it be like the switch, the M and the J?
M and the J.
On the little J M.
So I want to see, what is the probability that someone's wearing jeans is male? Jeans, male.
Because the jeans is the denominator.
No, I went the other way. Jay, let's slow down. Who's asking that question? Because realize this. This is males with jeans. This is jeans with males.
Okay.
And then are being male and wearing jeans disjoint? So my notes are I have 12 or both male and jeans. So it can happen. So that can happen. Therefore, it's not disjoint. Okay? Are gender and attire independent? Are gender and attire independent? Are gender and attire are gender? Oh man, gender. If I taught English, I'd be failing right now. Are gender and attire independent? So let's do this. Is the probability of a male equal to the probability of a male such that jeans? Well, but definition of independent is, are they going to be equal equations? So probability of being a male. How many people are we talking about?
17.
Out of how many?
36.
17 out of 36. So 17 out of 36 going to be the same equivalent fraction as probability of male such that jeans. Jeans is what? 20, right? How many males? So fraction freaks. Is 17 over 36 an equivalent fraction of 20 over or 12 over 20?
Yep.
It is? Okay. All right. Those are not equal. Therefore, they're what?
Yeah, because I was kidding.
Sarcasm. He's going well. These are not the same. Therefore, they are not independent. Okay. You have the rest of the period start on worksheet 1.4. Sound good? Have fun with it?